fluid coding, and AI here. Today, we are taking one normal engineering task and pushing it through the whole agent workflow: app, CLI, scheduled prompt, rubber duck review, code review, and the final merge decision. The question is simple. Does the platform help you steer and verify agent work, or does it just create faster code that still needs the same old cleanup? The useful test is not a spectacular demo. It is a boring task. Add a small validation rule, update the tests, and get the branch ready for normal review. Boring is the point. If the workflow only works when everything is fresh, isolated, and easy to explain, it is not a team workflow. A real team needs evidence: what changed, what ran, what failed, what was skipped, and what the agent thinks still needs human judgment. OpenAI now describes Codex as more than a terminal assistant. The app is positioned as a command center for multiple agents with separate project threads, diff review inside the conversation, editor handoff, and built-in worktree support. That matters because parallel work is only useful if isolation is obvious. If two agents touch the same repo, you need to know which copy they changed, which branch owns the work, and where the final diff lives. In the app stage, I would score the workflow on steering first. Can you interrupt the agent, correct the direction, and keep context intact? The research says the app supports reviewing changes in thread, commenting on diffs, and opening work in an editor. That is the right shape. The risk is that a clean chat can hide messy engineering state. A useful agent dashboard should make the branch, test status, unresolved comments, and next action impossible to miss. The CLI stage is where the task meets the real repository. Codex CLI can read, change, and run code in the selected directory across macOS, Windows, and Linux. The important detail is not just operating system support, it is control. Approval modes, sandboxing, command logs, and test output are the evidence trail. Full access can be powerful, but the team has to understand when the agent is only reading, when it can edit, and when it can reach outside the workspace. The cloud and IDE handoff are supposed to reduce friction. OpenAI says cloud tasks can be created and tracked from the editor, reviewed after completion, and opened locally while preserving context. For front-end work, Cloud Codex can inspect browser output and attach screenshots to a task or pull request. That is useful evidence, but it is still evidence to review. A screenshot proves what the agent saw. It does not prove the right behavior across the whole product. Scheduled prompts are the first place the workflow can quietly become operations. OpenAI Academy describes Codex automations as recurring tasks that run on a schedule and return results for review. Good uses are boring and bounded: a weekly documentation drift check, a morning failing test brief, or a Friday summary of unresolved agent work. The practical limitation is also in the research. Local automations work best when the laptop is awake and Codex is running. Automations also turn budget into a product feature. The Codex rate card says average cost is roughly $100 to $200 per developer per month, with large variance from model choice, running instances, automations, and fast mode. That is not a simple price tag, it is a behavior problem. A team needs to know which recurring tasks are valuable, which agents are running in parallel, and which reviews are worth the extra spend. Before trusting the agent as an implementer, use it as a rubber duck. Ask it to explain intended behavior, argue against its own approach, and list invariants that must remain true after the change. This is useful because it exposes assumptions before code lands. But explanation is not proof. Rubber Duck Bench found state-of-the-art models still struggle with code question consistency, with hallucination reported in 58.3% of responses on average. Treat the explanation as a lead, not a verdict. Code review is where the workflow should become more serious. OpenAI says Codex code review is trained to match pull request intent to the diff, reason over the codebase and dependencies, and run code or tests when needed. It can automatically review ready pull requests or be invoked with targeted instructions such as security or dependency review. The right expectation is not replacement. OpenAI recommends it as an additional reviewer, with citations, terminal logs, and test results for humans to inspect. The model evidence is encouraging, but it has boundaries. OpenAI reports GPT 5.3 Codex at 56.8% on SWE Bench Pro Public, 77.3% on Terminal, Bench 2.0, and 81.4% on SWE, Lancer IC Diamond. Those are first-party numbers, and they measure benchmark suites, not your repository. They support taking the workflow seriously. They do not remove the need for setup scripts, tests, branch protection, and maintainers who know what good looks like. Security is the part that decides whether the workflow scales safely. The GPT-5 Codex system card says Cloud Codex runs in an isolated OpenAI-hosted container with network access disabled by default, while local sandboxing restricts edits and network behavior depending on platform and settings. That default posture matters. The warning is just as important. Enabling internet access can introduce prompt injection, credential leakage, and license risk issues. More capability should mean more policy, not less. There is no verified first-party feature name that exactly matches agent merge in the research, so the safest definition is the final integration step. The agent-produced branch, diff, or pull request goes through normal repository policy. This is the accountability boundary. Tests should pass. Review findings should be addressed. The summary should explain what changed and why. Independent research on agent pull request lifecycles supports the same conclusion. Merge governance remains predominantly human. My verdict is that Codex looks most compelling when you treat it as an evidence-producing workflow, not an autopilot. The app is for supervision. The CLI is for local iteration. Automations are for bounded recurring checks. Rubber duck review is for finding assumptions. Code review is for extra scrutiny. Merge is still governed by people. For real teams, the winning setup is not maximum autonomy. It is clear isolation, clear logs, clear costs, and a merge policy nobody bypasses. If this helped you think more clearly about steering, verifying, and paying for agent work, like the video and subscribe to Fluid Coding and AI. The next time an agent hands you a diff, do not ask only whether it works. Ask whether the evidence is strong enough to merge.